Let's talk about a concept that you may already be familiar with, but when drawing Lewis structures, we may be able to expand it a little better. Hopefully all of you have heard about bond order. You know probably that the bond can be single, can be double, can be triple, and I remember probably this typical single carbon-carbon bond, the typical carbon-carbon double bond, and the typical carbon-carbon triple bond. However, sometimes that would be that the bond order here is 1, the bond order is 2, the bond order is 3, and that tells you a little bit about the distance and the strength of the bond, so on and so forth. However, sometimes the bond order is fractional, and that's what we are going to talk about. Sometimes the bond order is not 1 or 2, but it's 1.5. So let's see how we can detect those cases. And let's just use an exercise. In this case, it's asking for find the bond order and identify the shortest bond among the following compounds. We need to be able to draw the Lewis structures, so I will not stop at each of the steps to build the Lewis structure. I trust that you can do that on your own. That is why we are going kind of fast. Hopefully you can practice on your own. So let's see how the structure of carbon monoxide affects the bond order. We solved this one before, and this is, while not very satisfactory Lewis structure because it places the negative charge on the least electronegative, it's the one that maximizes the number of bonds and the one that makes follow the octet rule for both. So this is as much as we can say. So this will be a bond order equals 3. Why? Because it's a triple bond. There is 3 pairs of electrons being shared. For carbon monoxide, and again I'm going fast, if you count the number of electrons and make sure that all of them follows the octet rule, this is the carbon monoxide. There is 2 pairs of electrons being shared in both carbon-oxygen bonds. Therefore, the bond order for carbon-oxygen bond in this case is 2. Likewise, for methanol, and I'm leaving the interesting one for later. In methanol, well, let's do it right. Carbon, you're probably familiar with this, but notice that all of them, except for hydrogen, hydrogen does not need to follow the octet rule, but carbon and oxygen do. This is a single bond, there's just one pair, the bond order therefore is 1. Let's see now carbonate. Well, carbonate has 1 double bond and 2 single bonds. We've solved carbonate elsewhere, so hopefully this structure is not new to you. So how many or what order is the bond? Well, we have some resonance here, so carbon can be either single bonded or double bonded to oxygen, and these 3 structures, I'll be able to draw 3, are equally representative of the bond. So this means that we have to do an average of the multiplicity of the bond, either if it's single or double. So if you look at, let's just pick one because it's the same for both. If you look at this bond, in here is double, in here is single, and in here is single again. So what is the bond order? Well, it's double, it's single again, divided by 3 structures. This is 5. Sorry, I do not know how to add. This is 4/3, or in other words 1.33. The bond order, the carbon-oxygen bond order in this case is 1.3 or 1.33. Doesn't matter. Okay.